This is section 4.1, and we are talking about rational functions and their asymptotes. So this first part of this series, we're going to first talk about what is a rational equation or a rational function. A rational function is basically two polynomials being divided. So this is n of x, which is some kind of a polynomial, and this is d of x, another type of polynomial. And we just know that d of x cannot ever equal 0, because if it does, it will be undefined. So, in general, the domain of the rational function is everything but any number that makes d of x undefined. So we have to do some factoring with that bottom polynomial and set them equal to 0 to see what makes it 0. And those are the numbers that will make it undefined. So we'll show more examples of that in the next video. Here we have an example of 1 over x. This is undefined at 0, and because if I put 0 in for x, again, it's a fraction, undefined. So we have a asymptote here at 0, and we have another one right here at 0 going across. We have something called a hyperbola, and that's these two lines or curves that we have here. And notice that as I'm approaching 0 from the positive side, I can say as x is approaching 0 from the positive side, then we also know that f of x is approaching infinity. So when you see symbolism like this, as x is approaching 0 from the positive side, f of x is approaching infinity, that's what it means. Okay, so now look at if I'm going this direction. So as x is approaching 0 from the negative side, we can see that f of x is approaching negative infinity. It's going down here. I can say as x approaches negative infinity, f of x is approaching 0. And I could also say that as x is approaching positive infinity, f of x is approaching 0. We could also maybe refer to these zeros in this case as x is going in this direction. It's approaching 0 from the negative side. This one's approaching 0 here from the positive side.